Good day. My name is Uche Okeke. This presentation is going to be on the application of supervised data mining techniques to soccer data. So, what is data mining? In today's world, we're inundated with lots and lots of data. For instance, when we use our phone, or when we swipe our card at the ATM, or when we shop online using our computers. All these processes generate lots and lots of data. And data mining is a way in which we can get potentially useful information from this raw data. And we can do that by using computer learning techniques. So essentially, data mining is the process of employing one or more computer learning techniques to extract new and potentially useful information from this large raw data. Data mining techniques can be divided into two different categories: supervised data mining and unsupervised data mining. In supervised data mining, we build a learner model using data instances of known origin. In other words, we have data in which we know the class for each of the instances in the data. And then we use the model to determine the outcome of new instances of unknown origin. Unsupervised data mining is a data mining method that builds models from data without predefined classes. So in this data mining method, we don't know the class of the data in which we're trying to perform data mining on. Data mining has several applications in today's world. Here are just a few of the examples of how data mining is used in today's world. It's used in sales and marketing for market basket analysis. It's also used for banks to help them retain credit card customers. Insurance companies also use data mining. This allows them to detect risky customers' behavior patterns. And it helps identify the patterns of successful medical therapies for different illnesses. So, on to the problem statement of this project. The problem statement is to find any existing pattern and correlation between attributes in soccer data using supervised data mining techniques. For this project, we have decided to use supervised data mining technique, as we feel this is the technique that best suits the data in which we have acquired. The goals we'll be trying to obtain in this project is: 1. To create a model that predicts the outcomes of Arsenal FC football club matches with sufficient accuracy. The accuracy we have determined for this project is an accuracy of 70% when predicting the results of Arsenal match set. We feel that an accuracy of 70% will ensure that we are able to get good, reliable information from the data. The primary tool we'll be using for this project is called Weka. Weka is a data mining workbench created by the University of Waikato in New Zealand. Weka is an acronym for Waikato Environment for Knowledge Analysis, and it's a free open source software which can run on Windows, Linux, or Mac. It contains algorithms for classification, data preprocessing, feature selection, clustering, association rules, and much more. So, the approach we intend to take for this project is a four-step approach. First, we'll accumulate the match data to be analyzed. Second, we'll choose and test various machine learning algorithms. Third, we'll perform evaluation on the classifier in which we've built. And lastly, we'll apply test data to the classifier. This is the process flow diagram for the creation of our classifier. We feed the training data, that is the data we use to train our model. We feed the training data into the machine learning algorithm, which produces a classifier. Then the test data is fed into the classifier, and that produces results. And we can perform evaluation on those results to see how the classifier does when test data is input into it. So on to the first step of our process. Accumulate match data to be analyzed. The football data was gathered from footballdata.co.uk repository, and that's a repository that houses match data from several leagues in the world. Football data for this project was gathered from the English Premier League for seasons 2004 to 2013. The data was then split into 90% for training and 10% for testing. The next step would be to test the various machine learning algorithms, with aim being to find the best performing algorithm to which we're going to use to build our classifier. For this project, we've decided to test 5 machine learning algorithms. All these algorithms can be found on the Wicker data mining workbench. The first data mining algorithm we decided to go with was the baseline accuracy algorithm. Second was J48 algorithm. Third, JRIP algorithm. The fourth, naive Bayes algorithm. And the fifth, K nearest neighbor algorithm. Now, the first algorithm we'll look at is the baseline accuracy algorithm. It's important to have an algorithm that we can use to judge the performances of other machine learning algorithms. And in the Wicker software, the 0R algorithm is that algorithm. Essentially, it works by looking for the most popular class and guessing that all the time. The next algorithm we looked at was the J48 algorithm. This algorithm is a decision tree algorithm, and it works by selecting which attribute to split on at the root node, and then creates a branch for each possible attribute from the root node. The next algorithm we looked at was the JRIP algorithm. This algorithm is a decision rules algorithm, and it works by splitting the training set into 2 sets, a grow set and a prune set. The grow set adds clauses to the rules till a perfect set is obtained, while the prune set operates by deleting clauses till only the good rule is left. Up next is the naive Bayes algorithm. The naive Bayes algorithm is a probability algorithm, and it works under the assumption that each attribute is equally important and are statistically independent of each other. It uses the Bayes theorem. The Bayes theorem gives a formula for the probability of a hypothesis given evidence. In this case, the hypothesis H will represent our class, and the evidence E will represent the attribute of our instance. And that equals to the probability of the first attribute given the class of the instance, multiplied by the probability of the second attribute of the instance given the class of the instance. And that continues till we get all the probabilities of the attributes given the class. And then that's multiplied by the probability, by the prior probability, also known as the priori probability of H. And that's all divided by the probability of all the instances. So here in the formula, the probability of H is the priori probability, and it's the probability of an event before the evidence is seen, while the probability of H given E is a posteriori probability of H. In other words, that's the probability of an event after the evidence is seen. The last of our algorithms is the K nearest neighbor algorithm, and this algorithm works by making predictions by searching the training set for an instance that is most like the new instance and makes a classification based on that. So in other words, if there's a new instance in which we're trying to find out the class for, we take a look at other instances which are most similar to that instance, and then take a look at the class of those instances, and then we classify the new instance as those instances. Now, k-nearest neighbor helps prevent inaccuracies due to noisy instances, and it does this by taking into effect more than one nearest neighbor instance. So if you have a new instance and that is near several instances, it takes a look at k number of nearest instances and finds out the most common instance of all the nearest neighbor instances, and takes a look at the most common class of all the nearest neighbor instances, and chooses that as the class to which to classify the new instance. Next, we'll be performing evaluation on our classifier. For this project, we have decided to use the cross-validation methodology to perform evaluation. The cross-validation methodology shows the best performing machine learning algorithm in terms of accuracy. As shown earlier in the slides, we have decided to use 90% of the data for training and 10% for testing. And this is implemented in the cross-validation methodology. So in the cross-validation methodology, we divide it into 10 pieces. We take 9 of the pieces and use them for training, which represents the 90% for training. And then we use the last piece and we use it for testing. That represents the 10% for testing. Now we do this process 10 times, using a different segment for testing each time. The next step would be to apply new test data on the classifier. So in this step, new untested test data is applied to the classifier that we created. So onto the results and conclusion of our project. Below is a table that shows the machine learning algorithms and their accuracies of their predictions. The baseline accuracy gave us a prediction of 54%, J48 60.8, JRIP 62.3, naive Bayes gave us 52%, k-nearest neighbor 64.9. So from this, we can see that the naive Bayes gave us the worst accuracy, while the k-nearest neighbor gave us the best with a 64.9% accuracy. So some things to note: none of the learning machine algorithms met the 70% accuracy threshold we initially set for this project. And this threshold is important because we needed to find out if we could reliably trust the machine learning algorithms and the classifier we built to give us pertinent information about Arsenal FC Football Club's results. So because of that, because we couldn't obtain any classifiers that were able to accurately predict Arsenal performances, at least to an accuracy of 70% and above, we were not able to ascertain any reliable information using our machine learning algorithms. However, what we did learn is that we can accurately predict results just above 60% using the supervised learning techniques that we used. So here are some future considerations for the expansion of our project. Firstly, the creation of classifiers using more sophisticated machine learning algorithms. For this project, we have used some simple supervised learning machine learning algorithms. There are other more sophisticated machine learning algorithms out there which might be able to improve the prediction accuracy on the match data set. Secondly, adding more key attributes and integrating attribute selection criteria on the attributes. Thirdly, increasing the number of instances used. For this project, we have used 342 instances. Increasing the instances to over 1,000 might help improve the prediction accuracy on the match data set. And finally, the comparison of classifier prediction with bookmakers is the overall goal of this project eventually. So being able to produce a classifier with a prediction that can rival that of the bookmakers would definitely be the end game of this project. Thank you.